Hi guys. Yeah, Advait is coming. Is Advait coming, ma?
Yeah, he's coming.
Okay, good. Nisha, what are you doing in school, ma, Nisha?
Multiplying and dividing rational
I have to
fraction.
increase my speaker. Go ahead.
The multiplying and dividing the polynomial
Is
functions.
it easy or hard?
It's easy.
Okay. How about Ishita? What are you doing in school?
We finished cubic functions and cubit functions.
Okay. Okay. Before they go to that, okay, inverse of quadratic cubic functions you're doing. Okay, that's good to know. We started with rationals, right? Okay. So multiplying and dividing you're doing. So we have done that. So we can get on to. Let's see, ma. Basically, okay, we can do rational functions, expressions, and equations. Okay. Shrikar, what are you doing in school, Shrikar?
We're doing like rational addition and my camera's not on. Addition and subtraction, multiplication and division. So like, yeah.
I see. But what was the okay? I really want to know what was that we did last week from the book page. Yeah. Okay, that comes next for us. Okay. So we did addition, subtraction, multiplication, and division, right? Okay. Okay, I would like to go ahead and review a little bit and then go on to cubic functions. Ishita is covering cubic functions. Okay. Okay, let's see, guys. Rishit is coming in. Okay. Ishita, you're covering cubic functions. And Abhay, what are you doing?
Today we did graphing, what's it called? Rational expressions.
Graphing as well, you're doing?
Yeah.
Graphing rational functions?
Yeah.
Of
We
what?
haven't done we haven't multiplied or divided or added, subtracted. First thing we did was graphing.
Oh, you're doing is graphing. Okay, I see. I hear you. Okay. Okay, let's try this one. Oh, you know what? Rational function. Okay, word problems and rational functions is quite important before even we move on. So let's review what we did. We'll do a couple of problem types and then I'll move on with something else so that. Okay, how about this? 5 by 2x plus 6 minus 1 by 6 equal to 2 by x plus 4. This is just a review, guys. Go ahead and do that one. I really cover a lot of word problems in this. Okay, that's a hard part. We'll do that. And then we'll move on to inverse of simple quadratic and cubic functions. Finding function inverses is a good part, and then graphing square root functions. Okay, let's see. But I won't spend much of time on these because let's see. Akshada and Advait are coming. Okay, just do this, guys. I'll bring up the word problems. Annam, do you remember you're able to do, ma?
I'm gonna try.
Sure. Good. We don't. I don't want this so easy ones. Okay, we need to graph rational functions as well, but I'm not. I'll see. Okay, we'll do some word problems and then go on to graphing. I feel. Let's see. Okay, but before I go here, right? Did you guys get the answer to that? Rishit, what are you doing? Have you covered the word problems in rational functions?
Yeah,
What
we just
type
took
of?
we just took our key attributes test.
Okay. Oh, you have gone to graphing, huh?
Yeah, we just started graphing.
Okay. We can do the graphing part as well, but I need the cheat sheet. Okay, let's see. I would really like to go ahead and do the graphing today. Let's see then. And then we can move on to word problems. Have you covered word problems upstream, downstream, headwind, tailwind, distance rate? Have you done that, Rishit?
No.
Okay. I'm thinking you guys are doing that problem as a revision, right? You have to think about excluded values as well, guys. If you're stuck, you have to let me know. I got 2 answers. Advait, is that right, Advait? I don't think so, Advait. Oh, Rishit, that's right. Good job. Done, guys. Yes, Anisha, that's right. Guys, are you all able to do, or do you need help? I really want to know quickly.
I just need like a couple more seconds.
Sure.
Give me like a minute. I think I got it.
Yeah, take your time.
Priyanti, it's not letting me chat.
Okay, that's. Are you doing it from an iPad or not a laptop, ma?
Yeah, I'm on an iPad.
Oh, that's the problem, ma. You have to log in from a laptop. Looks like everybody who does it from a laptop is able to. Just reply to that. I think they have a bug. That's why we are not able to do. Are you able to reply to that, ma, Akshada? Correct, Shrikar. Good job.
Yeah, it's working.
Okay, that's nice. Okay, I'm going to wait, guys. Abhay, are you able to do?
Yeah, I almost have it.
Mm-hmm. So basically you can take out a 2 here. This will be 12 minus x, right? So this is 6. So 12 minus x by 6 times x plus 3 equal to 2 by x plus 4. So you cross multiply, should be fine. 12 times x plus 3 will be equal to x plus 4 times 12 minus x, 12x plus 48 minus x square minus 4x, 12x plus 36 equal to, then what else? 36 minus 48. Oh, I can get that. I bring x square here, I bring 48 here, so that would be minus 12 plus 4x equal to 0. So here it would be 4 3s are 12, but you need to have 6 2. Can I do 6 2? X square plus 6x minus 2x minus 12 equal to 0. X is x plus 6 minus 2, if you take it as common, x plus 6 equal to 0. So x equal to minus 6 or x equal to 2. Any questions, guys?
I have a question.
Yes, ma.
So can you also multiply x plus 4 on both sides
You
and
can.
then do it that way?
Yes. You can. There are multiple ways of doing it. Any acceptable method is good. And we did not discuss about excluded values here. Excluded values, this will be equal to 0 means it's excluded value, which is nothing but x equal to minus 3 is an excluded value, x equal to minus 4 is an excluded value. These two are not there in the solution, so these two are still solutions. Any questions, guys? Can I move on? Okay. Sequence might slightly vary, guys, but I am going to cover inverse variation and then graphing. Okay, so what are inverse variations? Okay, all the while in your 6th 7th grade and all, we always studied, hey, y is directly proportional to x. So we changed the proportionality symbol and wrote, hey, this is called the constant of proportionality. There is a multiplicative relationship between input and output. This is what we did. Here when you think about it, if y increases, x increases. Y decreases, x decreases, because there is a multiplicative relationship between input and output. You see? Did you all get that? So this is called, the proportionality is called direct variation. Any questions here? Okay. We are going to talk about inverse variation. What does that mean? I am saying y is inversely proportional to x. This is a symbol for proportional. People don't use it here though. Okay. This is direct proportion. This is inverse proportion. Meaning y increases, x decreases. Y decreases, x increases. That's what it means. So what do? Y will be equal to k by x. Meaning the constant of proportionality divided by x. So any input output. Any two quantities, let's say input and output vary inversely. That means if x increases, y increases, y decreases, x increases. So it's the opposite. So as a result, using constant of proportionality in your 7th grade, you studied this, right? Y equal to kx. K was the slope, right? Y by x. So here, when two quantities vary inversely, you write your equation as y equal to k by x. This constant will always be the same. X and y value can inversely differ. You got it? Let's see some problems. You'll be able to do it quickly. Okay. Now, let's say I say that y varies inversely with x. I say y varies inversely with x. Then what is the relationship between y and x? Y equal to k by x, or I can say x equal to k by y. Both are one and the same. The thing is, they are inversely varying, meaning one increases, one decreases. That's the main point around it. Okay. Now, I'm saying they are inversely varying, and I say y equal to 8 when x equal to 3. I say that y is equal to 8 when x equal to 3. And I want you to find out what is y when x equal to 12. I am saying that they are inversely varying. I am saying that y equal to 8 when x equal to 3. That means what is that you can get from there? If they vary inversely, just plug them in. Okay, this is 8, this is 3. So this k value, the constant of proportional, this k value is there, right? This constant that connects the input and output, that's 24. So that constant remains the same whatever be the x and y. X and y can change in their values. So now you know that they vary inversely. So you can use the same equation, but you don't know y. You know x and you know k. So using that, y will be equal to 24 by 12, which is equal to 2. Who did not get this? Who did not get this? From one given x and y, you find out your constant. Okay, that comes in inverse variations. Once you find out the constant is going to be the same in any pair of values, right? So using that constant, you will find one variable when you're given the other. Anisha, did you get it? Shrikar, I'm not able to see you. Can I move on? Okay, I'll go ahead, guys. Let's see. How about this? I'm going for a okay, let's say, how about this? Club goes for a trip in a bus. Okay, cost that each person pays to cover the cost of the bus. Cost for each person, you're going to do this, okay, is inversely proportional. Ishita, did you get it, ma?
Yeah, I understood.
Okay, so is inversely proportional to the number of people who go on the trip. To the number of people who go. Okay, I'll call them as P. You're going to construct, okay? Now, cost is 30 per person. Cost equal to $30 if P equal to 50. Okay, now what will be the cost, I'm asking, if 40 people go on the trip? Can you find out, guys? I've told that they are inversely proportional. So go ahead and try. Go ahead and try that. In the meantime, go ahead. I just want a nice...
What does it say next to the second cost that you've written down?
What, ma?
What does it say? Is it 3?
What is the cost? Second line is what is the
Oh,
cost?
that's a question.
Yeah. Sorry. Yes. You got it? Do you get it, guys? If you find it hard, you have to let me know. If you didn't get it, I have to know too. Did you guys get it? Yeah, bye. That's right. Subi, that's right. I think you all got it. Krishiv, I'm waiting for your answer. Avni, Krishiv, there were 2 answers in the previous problem. Avni, you missed it very slightly, I think, Avni. Your decimal placement is incorrect, ma. Anisha, correct. Rishit, is that the answer, Rishit? Advait,
No, that was
incorrect.
for a previous question.
Okay. Annam, not for this one, right, ma? Try, guys, let me know. Mm-hmm.
Miss Priya, I corrected my answer.
Yeah. Rishit, that's right. But what is it? 500, Rishit? I'm going crazy. What is that 500?
Um,
Avani corrected. Krish, yeah, go ahead.
so I calculated um if since the constant is 1500,
Okay.
and then we should calculate the cost for 40 people. For the first one, that's 37.5. And for the second one, if the cost is 3 people, the constant is 1500. So I got 500.
Oh, I didn't get it. Okay. See, I will ask you, Rishit. Okay. Cost is equal to K by P. They have given this one line sentence, right?
Yeah.
Cost is 30 if this is 50K. K will be equal to this is correct. Okay. And
Yeah.
after that, what did you do? C equal to K by P. I know that you got the answer. K is 1500, we found out. And they're asking for cost is what when P equal to 5.
Oh,
So
I read a 3.
C will be equal to
Miss
150 by Yama
Miss Priya, can you check my answer?
37.
I read cost as a 3.
Oh, okay. 37.5, guys. Good job. Now I have some questions which are a little bit twisty. Let's see. Easy ones you know now, okay? How about this? It's a good one. But easy one though. Try this one. Quick, come on. We can move on to further harder ones. I want two answers 14 and 16. Try, guys.
Miss Priya,
Hmm.
in the first problem, does it say is that a period after the y
Yes, after
cubed?
the y, yes.
Okay.
X varies inversely as y cube. That means what? X and y cube are your quantities. So varies inversely means x equal to k by y cube. Can you try that?
Wait, does that say y cubed for the first question?
Yes, ma.
Okay.
Did you guys get it? If you are not knowing, you have to let me know clearly, quickly, guys. You cannot keep quiet. Krishav, are you following Krishav?
Yeah, yeah.
Okay. Annam, yes, I can. Anisha, correct, ma. First one is correct, waiting for the second. Abhay, first one is correct, waiting for the second. Subi, the first one is not correct. Akshada, the first one is correct, waiting for the second one. Okay, guys, on the first one, right? It goes like this: x varies inversely as y cube. That means what? They're not direct, meaning both. See, when they are directly proportional, both will be in the numerator on either side because one increases, the other has to increase. If they are inversely proportional, that's the opposite, right? K by y cube. So that's the relationship between x and y cube. This constant of proportionality. this constant will be the same. So x equal to 16, just plug in. When y equal to 5 means this is 125. So k, don't multiply unnecessarily. 125 times 16 is your k value, but I can use the same k value for this one. Rewrite your thing. X will be equal to k by y cube. Rewrite that. Now substitute k, substitute y. Y will be equal to 2 to the 4, 4 to the 8, right? Here you have 125 times 16 equal to x. So times 2, x equal to 250. Subi, did you understand what was the mistake?
Yeah, I forgot to cube it the second time I plugged it in.
Okay, makes sense. Ishita, are you following? Advait, are you following?
Yeah.
Okay,
I
now
sent you the answer. I got it right.
I gave you the answer, right, Advait?
Well, no, I solved it before that.
Yeah, but you can see the answer always, right? Yes, Anisha, that's right, ma.
Priyanti, can you go back?
X is 250, not 25, Advait.
I sent 25. Or what?
Answer is 250.
Oh, I think I had a typo.
Yeah, Rishit, the second answer is asking whether it is A, B, C, D, right?
Okay, I'll do that.
Yeah. So the second one says W vary inversely as the square of t, means W and t square are the two quantities. Okay. So here W equal to 12 when t is equal to 2. That means t by 4, right? T equal to 48. Now with that, I'm sorry, k equal to 48, right? So with that same k, what I can do for the next set, I can do the same thing. Rewrite your equation k by t square. They're asking 27 is w. You know k is
So wait, is it B then?
yeah. So t square will be equal to 48 by 27. Okay, now 3 ones are 3, 3 6 are 18, 3 nines are 27. T square is 16 by 7. T will be equal to t will be equal to 4 by 3. However, that's not what is asked. So basically, what are they asking? 27 t square will be equal to 48. That's what it is. Any questions? So now inverse variation we are good, but I want to give you a problem on joint variation. That with all this, that is going to be a little tricky. Let's see. Okay, how about this? Let's see, this is an easy problem. This is not on joint variation, but if you find this difficult, then I'll do on the board. Guys, try guys. An experimental drug is given to 100 people with a certain ailment. 53 people of these people were cured by the drug. Select the statement of condition for the expectation of a cure. C, if 2000 people with the ailment are given the drug. So it is just making a proportion out of it, that's all. I want to give you a problem on joint. Don't know. Inversely. Yeah. Okay, that's good. Did you get it, guys?
Yeah.
These problems are easier though.
Wait, can you check if I got it right?
Sorry, ma. Oh yeah. Yeah, Subhi, Akshada, Annam, correct. Krishiv, correct. Shrikar, is it B or C?
That was for the last question.
Oh, okay. So here the answer is C. So experimental drug is given to 100 people, 53 of these people. So administered divide by cured will be the same ratio, right? Administered divide by 53 people were cured by the drug. Select the statement. 2000 people with the ailment were given the drug. Okay, so we need to 100 by 53. So 100 in the numerator, 2000 in the numerator, or it can be other way. 100 in the numerator, 2000 in the, it can see. If 100 divided by 2000 can be the same as 53 by C. 100 divided by 2000 can be equal to 53 by c. It's not c by 53. You cannot get confused here. So, or it can be 100 by 53 equal to 2000 by c. This is also not correct. This is also not correct. What is correct? 10 by 53? I don't think 10 by 53 is correct. But here, c, the reciprocal of the c by 2000 will be equal to 53 by 100. Answer is c. Any questions, guys? Okay, I'm going to do the next one. Joint variations. E, guys, are all of you listening? E varies jointly as f and G. Oh, okay. E varies. There are three quantities in here. E varies jointly as F and G. This side you have F and G, this side you have E. But it is varying jointly. That means it is proportional. So it is equal to, E will be equal to the constant time Fg. All are in the numerator. They are just varying jointly means there are multiple quantities involved. That's all. Okay. So now an E equal to 24 when F is equal to 3 and G equal to 2. So K will be equal to 4. Any questions, guys? You see jointly means E is one quantity on one side, the other side you should have K, F, G. Any questions? Okay, inverse variation problems are all easy provided you get a hang of it. How about this? Yeah, you can do that at home, guys. I don't want to do. So you should be able to say whether it is inverse variation or direct variation. Now, guys, let's suppose x. How about this? So y by x equal to k. What type of variation is this, guys? What type of variation is this?
Direct.
Direct variation.
Linear.
Direct variation, ma. See, y increases. Then when you multiply by x on both sides, x as well increases. You see it? You see it? And then, and then suppose if you have y equal to k bar, let's say y by k will be equal to x. Y by, what is this? What is this?
Direct.
Direct again, but you just need to be careful. Okay, so here xy equal to k. What is this variation? They can give you in any format, guys.
Inverse.
Inverse. Y divide by x on both sides. You'll clearly see y equal to k by x. Do you see? This is why it is inverse. Any questions here? So we have covered a direct variation problem. We have covered several pieces. Okay, the rest of it you can do at home. This is a simple one. Now, let's go ahead with graphing of rational functions. Okay. Now, what is the rational functions? Numerator is a polynomial, denominator is a polynomial, right? So a graph, a simple parent rational function is basically this. But how do you plot the graph of this? As and when you, meaning as and when you're asked to plot the curve of anything, right? The easiest way is put the input, put the output. Okay, input is your independent value. You can have any value, minus 10, minus 5, minus 2, 0, 2, 5, 10. Now, f of x is 1 by x means minus 1 by 10, minus 1 by 5, minus 1 by 2. But here, 0. It becomes 1 by 0. Division in mathematics says it is an undefined operation. 1 by 2, 1 by 5, 1 by 10. Any questions still here? I am just drawing a table with input output values. Input is the independent variable and it can be anything, any value that you give. The output is dependent on input and you plug it into the equation and put it in here. So now, first let me see. So here you have minus 2, minus 4, minus 6, minus 8, let's say. Now, minus 2 has a, here as well, let me go ahead like that, okay. 2, 4, 6, 8, 10. This is minus 2, minus 4, minus 6, minus 8. Now, here as well, 2, 4, 6, 8. Now, I'm going to plot and show you how the parent rational function appears on a graph. Minus 10 on the left side is a minus 1 by 10. Okay, minus 5 here is a minus 1 by 5, a little up than that. And then minus 2 is a minus 1 by 2, a little more up. Okay, 0 goes to undefined. Undefined means it tries to go in parallel to the y-axis forever. We don't know where it is going. Okay, Now it is undefined, means at 0 the function graph should not be present at x equal to 0, meaning the function will not have its graph at x equal to 0. Now for 2 it's a half. 2 it's a half. So somewhere here, right? Oh, I'm sorry. Yeah, 2 it's a half. And then 5 it's a 1 by 5, it's less than that, and then it's a 1 by 10. It's even, it's trying to merge with the x-axis, but it is never going to merge. So what happens at y, the function is not defined, right? So somewhere from infinity it comes like this and then keeps going like this. Make sense, guys? So at 0 point, when you think about it, the graph does not have a value. So this is the parent rational function 1 by x. Is it an even function or an odd function, or what it is, guys? Any guesses? We have discussed this property when we talked about the types of functions which we learn in algebra 2 right at the start of the year. How will you determine whether a function is even or odd?
Based on the
Based on the
amount of x's.
Do you all remember, meaning there are two ways of finding whether a function is even or odd, right? Algebraically, if f of x equal to f of minus x, then it is even. F of minus x equal to minus of f of x, then it is odd. Remember, guys, this is even function, this is odd function. This is algebraically. When you look at a graph, how can you quickly say this function is even or odd? If the function is symmetric about the y-axis, it's an even function. If the function is symmetric about the origin, then it's an odd function. So, given that, can one of you guess what is this function? Is it an even function or an odd function?
It's an odd function.
Yeah, why?
It's
Why?
symmetrical. It's symmetric about the
But
origin.
why? Yep, it's symmetric. Yeah, it's symmetric about the origin, because when you think about it, right, this point, right, from this point, this is equidistant. Similarly, this point, see, with if I have origin as the mirror, I can pull this down and then reflect it. Do you see? That is why it is symmetric about the origin, so it's an odd function. Any questions, guys? Now, how will you verify algebraically f of x equal to 1 by x? Who said it's an odd function? What you will do, you will substitute minus x wherever you see x. Let's see what happens. If I substitute that, what happens? F of minus x will be minus 1 by x. It is not equal to minus of f of x. I'm sorry. So here, suppose if I substitute minus x, instead of x, I substitute minus x. So what happens here? This as well gets a minus x. So f of minus x becomes minus 1 by x. Any questions, guys? Now, when you look at it, right, here f of minus x is not equal to f of x. Only if that's the case, it's an even function, right? Here, yeah, the f of x is here, but there is a negative sign. So f of minus x equal to negative of f. So this is an odd function. Any questions, guys? This is the algebraical way. Okay. Now, how about this? I would really like you to, okay. Oh, yeah, before I go forward, right, we were discussing the graph of a rational function. Remember, I'm going to go there and ask you a couple of questions on the properties of the graph. Let's see quickly. Yep. Now, coming to the parent rational function, guys. Plotting this function is so important, guys. Okay. Now, coming to this function, right, ma? So tell me, what is the domain of this function? Are we doing it correct? 1 minute, wait. Are we doing it correct, guys? Is this graph correct?
Yeah, it is.
Really?
I think the graph, it looks correct.
Are the points correctly plotted?
Um,
I'm glad I came back. Are the points correctly plotted?
it's really hard to tell.
Amma, the points are here and the quadrants you know, right?
Oh, yeah. Oh, no, I don't think so, actually.
Exactly. So
They're like
negative,
flipped.
negative. Yes, it should be here, 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 and then goes here. So it goes like this, right? This is the graph, guys. 0 is undefined and this is your graph. You got it? For the points, when I plotted it into the wrong quadrant by mistake. None of you picked me at all. So see here, negative, 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 negative. So this is the quadrant, and then positive, 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 positive. So 1 and 3 quadrants, right, guys? So the graph of 1 by x is this. It is still symmetric about the origin though. Okay. However, the graph is like this. See, I had that instinct. That's why I came back. Now here, this is the graph of the parent function 1 by x. You all know that it is an odd function. Why? It is symmetric about the origin. Origin odd. Okay, now if it is symmetric about the y-axis, then it's an even function. Otherwise, what do? Instead of x in the function f of x, algebraically, if you want to find out, you will substitute minus x wherever you have x. When both are equal, then it's an even function. When both are not equal, then it's an odd function. Okay, meaning when both are not equal means f of x is equal to f of minus x means even. F of x equal to minus of f of x means it is odd. When none of these relations holds good, it's neither. Okay, this is something we learnt before. I'm just revising. Now what I want you to know is the graph of rational function. Can I move on basic? Okay, now before I get going with more, I want to know what is the domain of this function, what is the range of this function. Who can tell me the domain of this function, range of the... Let me draw it nicely, guys. Okay, rational function, parent rational function. Okay, the equation is f of x equal to 1 by x. So the graph is here, right? Now, what is the domain? What is the range, guys? You're going to tell. For the domain, I want it in 3 notations. For the range, I want it in 3 notations. What are they, guys? You go ahead and tell. You have seen the graph, right?
Um,
Go ahead.
for what's it called? I forgot the name of the thing.
Okay, guys, there are 3 notations.
Oh yeah, notation. I
Set
forgot the
notation,
notation.
interval notation, inequality notation. You cannot afford to forget, okay?
Okay, yeah.
Anybody, not just him, please. Okay, interval.
Interval notation, it would be negative infinity comma 0.
Yes, in interval notation. So it starts at negative infinity, comes to 0, and then at 0 it's not.
I have to go.
You have to go? Okay.
Yeah.
Okay, Krish, go ahead.
And then it'd be 0 comma infinity.
Yup, union 0 comma infinity. See, all these are parentheses. Don't confuse with square brackets because 0 is not included. At 0, the graph is not there. In inequality notation, same thing can be defined as at infinity less than. There is no less than equal to because these are all parentheses. It goes like this. Set notation, you will put x and then say, what will you say about x? X is less than 0 or x is greater than 0. It's not equal to 0, right? So you have to account for that. Okay, and then finish the curly braces. These all the notations I'm revising after a long time. Anisha, are you following, ma? Rishit, are you here? Please don't switch off the videos.
That zero in all of these will change as the asymptote changes with the function shifting.
Yes, it will. That's what we are going to study about.
Wait, Miss Priya?
Miss Priya, my screen's breaking. Can I rejoin in a minute?
Sure. Yeah, go ahead.
Wait, for set notation, do you not put negative infinity is less than 0 is less than infinity?
Absolutely, you can put the same thing in there.
Oh, okay.
Okay. As long as you convey the same meaning, they will not be bothered. How about range? Range is what? Range is going to be the same, right, guys?
Yeah.
Range is going to be the same as well. And what is end behavior? As x tends to minus infinity, y tends to
Minus infinity.
X tends to minus infinity. The graph tends to what?
0.
0. As x tends to plus infinity, f of x, y tends to what?
0.
Yep, that's your end behavior. These are things that I'm revising after a long time. Okay, properties of rational functions. Can I move on? Can I move on, guys? So, now we have covered transformations. So, I would be brave and go ahead with saying, hey, f of x equal to 1 by x, right? Now, let's say if I have f of f, I don't want to use f dash, okay, g of x equal to 1 by x minus 1. What is this, guys? What is the transformation? Basic transformation we have already covered. So what is this transformation? Minus 1. What is a transformation? Who can tell me, guys?
Isn't it right one?
Good job. It's movement to the right one. Movement to the right one. How about this?
Movement to the left one.
Yup, movement to the left one. Okay, great. Now it was with the x, right? That's why it's on the horizontal axis. Okay, now how about this? G of x equal to 1 by x plus 3. What is this?
It goes up 3.
Up 3. How about 1 by x minus 3?
Down 3.
Yep, down 3. So basically what happens, guys? A graph like this, down 3 means what happens? The graph becomes like this. That's it. 3 down, right? So it becomes like this. So 3 becomes your asymptote. Minus 3 becomes your asymptote. Am I making sense? Okay. Suppose if you want to move to the right, let's say 1 by x plus 3. You want to move to the left, right? Actual graph is this. You want to move to the left 3, right? So what happens? What will be your asymptote? Who can say? What will be your asymptote then? If it, see, the asymptote itself moves left 3. This is the x equal to 0 line. What will be the asymptote then?
Negative 3.
Yeah, x equal to negative 3. That line moves 3 units to the left. That's all. You got it? Up down means y equal to 0 line is your asymptote, but it moves up or down. Here y equal to minus 3 is your asymptote. Any questions, guys? Okay. How about this? I did not discuss everything, right? So how about this? H of x is equal to 2 times 1 by x. What is that? Who can tell me?
A vertical stretch?
Vertical stretch by 2. How about half? 1 by 2x means what?
Horizontal compression by 1/2.
Oh my god. Okay. Horizontal.
Compression by 1/2.
Correct. Horizontal compression by 1/2. Okay. Okay. Anybody not able to grasp this? See, this is the graph I asked. So this can be written as g of x is equal to 1 by x is your original function. You got it? Now, the denominator 1 by x is your original function. So when you look at it, right, when you multiply something with x, this you're multiplying with your y value. This one you're multiplying with your x value. Whenever it's multiplication with x, right? Whenever your multiplication is with the x value, right? It is horizontal stretch or horizontal compression. But the number that you multiply with x, right? You have to reciprocal and say that is the factor. So 1 by 2 is the factor. If the factor is 1 by 2, it is less than 1, so it is a compression. So horizontal compression by half. Did you all get it? How about this? T of x is equal to minus 1 by x. What is that? What is that, guys?
A reflection over the x-axis?
Reflection. This is a reflection over the x-axis. Good job. Because the y value completely got negated. For a point, if you reflect it on the x-axis, right, the 1 comma 1 point will become 1 comma minus 1. When the y value gets negated, it's a reflection on the x-axis. If you reflect it on the y-axis, the x value gets negated. See, 1 comma 1 becomes x value gets negated, means reflection on the y-axis. Here, the entire y value became negative. So, it is a reflection on the x-axis. Now, one last one I am going to give you. How about this? P of x will be equal to minus 1 by, wait. I don't want to give this. P of x equal to, Rishit, you tell me what is this? What is that?
It's horizontally stretched by 2.
Nice. Then what else? Horizontal stretch by 2, and then what else? Because
Flipped on the y-axis.
And then what is that, my reflection on?
Y-axis.
Y-axis. Because of that negative, it's a reflection on the y-axis. See guys, transformation is pretty easy if you're all following it. Okay. Now, we are going to get into harder graphing. Okay. How about this? Let's go ahead and try this one. G of x will be equal to 3 times 1 by x minus 1 plus 2. What is this, guys? Can we go ahead and first write down? Let's write down the verbal description. That's the way to graph nicely. What is the verbal description? Initially, whatever we learnt right in the first class, only we are going to learn again in June. What is the verbal description here of what are
Vertical stretch by 3.
Vertical stretch by 3. Good.
Just left one.
Left one.
Right.
Right 2. Yeah. So
Wait.
you know.
It's
Yeah,
right one up 2.
It's right one up 2, yeah.
Sorry. Left one, right, guys?
It's
Left.
right
No, because
one.
it's minus 1.
Oh, oh my gosh. I did not sleep yesterday and that is making havoc on me. Okay. So this is minus 1 means it's going to go right. Right 1 up 2. So now this is your graph, right? Usual graph. This is your parent graph. Now I am going to show you how it is going to move literally. So vertical stretch by 3, right 1. Okay, now if when you want to draw transformation graphs, right, I always want you to have 3 reference points. What are the 3 reference points for this? Let's not go here, okay? Let's not get into the problem. But f of x equal to 1 by x is our graph, correct? Now, with this 1 by x graph, what are the 3 reference points you can have? Can I have this and this? What are these 2 points? See, if I put my x value equal to 1, y value equal to 1. So 1 comma 1 is always a reference point for me. Then minus 1 comma minus 1 is another reference point. Are you with me, guys? Are you with me?
Yeah.
Yeah.
Okay, good. So
Yeah.
these 2 are the reference point. Okay, so basically reference points are 1 comma 1 minus 1 comma 1. These play a big part in the transformation graph. Another important aspect that plays a part in the transformed graph is vertical asymptote, horizontal asymptote. What are they? Vertical asymptote is, what is this line called? Equation.
X equals 0.
X equals 0. What is this line? Horizontal asymptote is?
Y equals
Y
0.
equals 0.
equals 0. So this is so very important, which I forgot to say when we discuss the properties of rational graphs. First, need to know any graph, right? Before you go to transform functions, you need to know what are the reference points for the parent graph, what are the vertical asymptote, what are the horizontal asymptote. Once you know that, things become very easy. How? Why? Let me tell you. I don't know, some of you were here when we discussed transformation early on, some of you weren't here. Okay, the way I want transformations of graphs to be done is, I would like you to draw a table. You will never make mistakes in this. Okay, this is so good, a reliable way of doing parent function, transform function. Okay, now x, f of x, parent function was 1 by x. You know the reference points were minus 1 comma minus 1, 1 comma 1, and then x equal to 0 was your vertical asymptote, y equal to 0 was your horizontal asymptote. For rational functions, the initial graphing is very easy, but when you move a little step up, it is going to become very complicated. So unless you understand this, things will become very hard. How about this? For the transform function, I'm going to write down what I'm going to write down. See, writing this piece is your treasure for the transform function. How it is going to change? We have written the verbal description. Vertical shift by 3 will affect the y value. Right 1 is going to affect the x value. Up 2 is going to affect the y value. Right? Vertical shift by 3 means y is multiplied by 3. First of all, I have to write how x value transformed. How did it transform? X just got added with a 1, right 1. We did that. How did y get transformed? It got multiplied by a 3 and added to a 2. Any questions, guys? Any questions? Now it's very easy. You just add 1 to the 0, 1 plus 1, 2, and then x. What is the asymptote? X equal to 1 is your vertical asymptote. Now what happens? 3y plus 2, please plug in values. Minus 1 if I plug in, right? Minus 3 plus 2 is a 1 now. And then what happens? If you plug in 1, it becomes a 5. Now your horizontal asymptote, what happened to your horizontal asymptote is y equal to 0. It moves up by 2, right? So basically y equal to 2 is your horizontal asymptote. We know everything to draw a graph. Okay, rational function graph, always on rational function graph, please start with your asymptotes. X is equal to 1 is your asymptote. Y equal to 2 is your, horizontal asymptote. So, you know what? Y equal to 2, x equal to 1. The graph, oh, what did I do, guys? Did I make a mistake? I'm not able to write on the board
Miss
now.
Priya, I think when you plug in -1, it's supposed to be -1 for 3y plus 2.
Oh, did I? Where, ma? 1 minute. Here, 0 if I plug here,
Yeah.
did I plugged in -1? Yes, thank you. Thank you. Good job. I did not go there. I would have found out the mistake. Thank you. Okay. So now, did you understand? First, you'll start with where is your vertical asymptote, where is your horizontal asymptote. See, in a parent function, it's very easy for a rational function. So this and this is your asymptote. So the function comes like this. Okay. But finding in a transform function, always start with vertical and horizontal asymptote. You know where is your x. This is not the function, but you know where your meaning how your function is going to be, either this or it's going to be this, something of that sort. So that x is in here that you will know. Okay. After that, it's pretty simple. I don't want the black lines. Okay. You know the asymptote. After that, it's pretty easy. 0 comma minus 1. 0 comma minus 1 is a point on the graph. And then what? 2 comma 5 is a point on the graph. 2 comma 5 means 1, 2, 3, 4, 5. 2 comma 5 is a point on the graph. Do you see, guys? So it's going to be like that. Meaning, see, these 3 points are not enough. Okay, you need to have more points. See, unless and otherwise you plot at least 2, 3 more points, you cannot have the graph. But for now, I can say that the graph is going to be like this. Any questions, guys? Any questions?
No.
Yeah, but you need to have more points, ma. Okay, so minus 1 comma minus 1 became 0 comma minus 1, correct. 1 comma 1 became 2 comma 5. Okay, now in this transform graph, let me draw the transform graph a little clearly. This was x equal to 1, right? X equal to 1. Y was this was y was 2, right, ma? Y was 2. So I had my graph like this. Can you tell me what is the domain and range, please? Who can tell me the domain and range? That's quite important. I'm just going to write an interval notation. Who's going to help me? I don't want to pick, guys. You guys can volunteer, make mistakes. Then you will figure it out. The learning happens here. Tell me, guys, what is the domain and range?
Miss Priya, that says x equals 1, right? X equals 1.
Yeah, x equals 1.
Okay.
This 1. Y equal to 2. Do you want to say domain, Subi? Just try it. Start from minus infinity, right? Where does it go? Till what it goes? See, x values exist, right? From minus infinity to what it exists. All x values are valid. Do you see? What is the x value that's invalid? Guys, am I clear or no, guys?
X equals 1.
Yeah,
X
x
equals
equal to 1. So from minus infinity to 1 it's available, but at 1 it breaks. It's undefined, right? So you need to have this bracket, this parenthesis. Union at 1 you don't have the value, but then on the right side when you see, right, from that 1 it goes to infinity. That is domain. For the range, who can help me?
Negative infinity to
Yeah, from negative infinity till where are you going?
2.
2. Negative infinity to 2. And then union 2 to infinity. Why? 2 it starts here and then it goes on the level. Meaning it raises up, right? Any questions, guys? Okay, that was a fast class, I felt. Okay. Okay, let's see this one. One more. How about this? I want to cover this. Okay. Let's try out. We will only do very basic functions. Okay. Next week it's going to be a little tricky. Please attend the class. Rational function graphing. It's one of the very tricky concepts. How about this? Minus 0.5, 1 by x plus 1 minus 3. Do you want to try and show me the graph? Would be very nice if I can see the graph. Can we try? You know what I want to know? I want to know what, okay, from my parent graph, minus 1 comma 1, can you plot the point in the transformed graph? Plot that point in transformed graph. Number 1, okay. Number 2, also plot this in the transform graph. With that, we'll finish. And please show me the graph and you can leave.
Miss Priya, okay, never mind. I'll just finish this up.
Yeah, thank you, Abhay. I really appreciate that, Abhay. Let's try to graph this one, guys. If you don't, it's okay. See, I will start with verbal description. Okay, then I will write verbal description affects the x point and the y point. Then I'll go ahead and draw a table, parent function.
Do we need to show you a graph on our paper?
Yeah, sure. And then just send where does the point move to. Minus 1 comma minus 1 in the parent move to what point in the transformed graph. 1 comma 1 move to what point in the transformed graph. If you give all this to me, it's that you understood. This is the very basic transformed rational function. You can do till... Please do the homework this week, okay? Otherwise, next week you can't understand anything, I tell you. Yeah, ma. I'm almost, ma. Mushtalaka. How was it?
Good.
Inverse variations and
They see?
1 minute, ma. I know all of you guys know about inverse functions. Inverse function, jointly proportional, all that you guys got it. But the harder piece is graphing rational functions. It'll be a smooth curve when you do it in school. Definitely do it at home. Do it at home. Find at least 5 problems to do it, and then come back to class. Next week, when we really go to the harder ones, you'll be amazed to see how easy it is. If you don't know, please tell me, I'll help. Oh, Anisha, you got it, Amma. Okay. Oh, Anisha, just 1 second, give me.
I think I messed up because it's weird. It's
One, I'll check. I'm checking, ma. -2. Okay, Anisha, do you know how to plot it, ma?
I did.
Anisha, you know how to plot it?
Yeah.
Then you can leave, ma. If you know how to plot it, don't worry. You can leave. But if you're doubtful, do it and go.
Priya, is this correct?
1 second. 1 second. Oh, yeah, that's correct. That's perfectly correct. That's perfectly correct.
All right.
That's nice, Shrikar. Hey, guys, did you get it? You can take time, but you're going to figure it out. Is it? Show me, ma. I can quickly see. Oh, yeah. Good, ma. Good, ma. Good, 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 good.
Did they get it?
Yeah, yeah. You got it.
Bye, Miss Priya.
Bye, guys. Because if this becomes harder next week, you cannot understand anything. Avyukt and Pratika, you're going to give me 2 minutes time. Okay, I'll just get up, go and come back. You got it, Abai? I really appreciate. You have to bring it in front, Abai. I don't know. I'm not able to see. Thank you. Is it coming like that, Abai?
My drawing might just be pretty bad, but I think I got my points right.
Okay. What are the points?
I got -2, -2.5, and
Yes,
then
yes. Good job. You got it.
C.
Bye, ma. So, guys, here when you think about it, this is minus means reflection on x-axis. 0.5 1/2 means vertical compression by half. Then what is this? +1 and -3, down 3, and then what is this? Left 1. Okay, now this affects the x-axis, this affects the y-axis. Vertical means affects the y, reflection on x-axis means affects the y. So my x points, how did my x points change? X +1, this is the only thing. Y, what happens to the y? It becomes -y. then multiplied by half, minus half y minus 3. That is the transformation. So please plug in these points. Minus 1 if I plug in on the x, right, what happens? Minus 1 if I plug in on the x, this minus 1 point, what did it become? 0, right? Right? Minus 1 point. I'm sorry, wait. Plus 1.
Miss Priya.
Wait. X plus 1 means it went to the left, right? So this is going to be x minus 1. As a result, if you plug in minus 1, this minus 1 point x coordinate moved to minus 2. So this one became let me put it in a different color. This one became minus 2. Again, the y coordinate of minus 1. What happened to that? If you substitute, this becomes half minus 3, which is minus 2.5. Right? Now you plug in 1 here, 1 minus 1. 1 minus 1 becomes 0. Now again plug in 1 on the y, so that becomes minus 3.5. Any questions, guys? So this point moved to minus 2 comma minus 2.5. This point moved to 0 comma minus 3.5. Annam, did you get it?
Miss Priya,
Yeah, ma?
is this right?
I can check, ma. This is a difficult part, guys. I understand. Show me, ma. Sorry, you have to bring it in front. Where is the graph, ma? Where is the graph? I need to see the graph. Without that, I can't say anything. Johan,
Like,
you have to bear with me for 5 minutes. What, ma?
how do I draw the
The
graph?
graph. You have to put in more points. These points are not enough. That's what I'm saying. You have to put in more points. Put more points for x and y in the parent graph. Then make the movements with this. You get it, ma?
Yeah.
So you have to at least put 3, 4, 5 more points. These two are not at all enough. What will you understand from these two? So the graph should be something like this. It will be something like this. And then this side is going to be something like this. You got it? This will be your asymptote. Make sense? That was a difficult one. You have to give me. But I'll continue with that again next week, guys. If you have any doubts as well, bring it back. But that's why I'm saying go through the examples in the book and you'll really get it. The way we did, follow the verbal description, write down what x or the y point it affects, and then based on that, put the transformed points x minus 1 minus half y minus 3 based on what happened on the y. Reflection on x-axis means it became minus y. Then vertical compression means minus y was multiplied by half. That's what is written here. And then down 3 means minus 3. So it becomes a little, this is where it becomes a little complicated. Okay. Anam, are you getting how I got it?
I understand that, like, based off of what each, like, variable of the thing you're plotting the line, but that's kind of all I really understood.
Okay, but
So,
you
like,
did
so like I get that, like, negative 0.5 means it's like compression, and then it's getting reflected.
Yes.
But I don't really understand the like function of all of the parts of the function. You know what I mean?
Okay, so you did not understand the transformation, is it? This one.
Yeah.
I'll do one thing. You were not with me for the first part of the year, right?
Yeah.
See, that's where everything is gone. Everything has gone amiss. Okay, basically, any function will follow the same transformation. That is why I'm not reteaching, because it is going to take a hell lot of time. You see what I mean? Huh? So what I'll do is, I'll go ahead and get you those assignments. Look through that and let me know next week. If you want, then you have to come a little early, ma. Make sense?
Okay. Yeah, I'll look through the text, like the book you gave us.
Book is there. Yeah, book is there, but you have to understand this a little bit more. I'll give you a separate assignment. Ping me for it. I will let you know. If possible, if I have a video, I'll send it as well.
Okay.
Okay, okay, ma.
Mhm.
Ishita, did you get it or you had the same problem? You were not with me as well, right?
Yeah, I got the transformations because I already did that, and I just having trouble on graphing it.
On graphing it. Okay.
Yeah.
Okay, I'm listening. I will send maybe some detail to Ishita and you have to ping me separately. Okay?
Okay.
Okay, guys. Akshata,
Okay.
did you get it?
Yeah, I feel like I would get it once I like start doing the homework and all.
Let's see. But definitely please do look at the homework and then come back. Okay?
Yeah.
Okay, ma. See you all next week, guys. Have a nice week ahead.
You too.
You too.
Bye.
Thank you. Bye.
Bye, ma.
Bye.
Bye, guys. Hey, give me 2 minutes. I know we are 10 minutes late, but please give me 2 minutes. Sorry, guys. Can we go ahead? Okay.
Miss Priya,
Yeah, ma.
I have a question.
Please go ahead.
So, I'm going to ninth grade next year, right? So we have course selections and they're like due soon. So I'm thinking I'm probably gonna take the CBE for geometry like in April. So should I just put in geometry like honors right now as a place?
And then switch.
Okay.
You will put geometry honors now for next year, but since you'll take the CBE, automatically they will switch when they put up the schedule after you pass.
Oh, okay.
But Pratika, how confident are you with geometry, Pratika?
I think
Confident?
yeah.
You've been doing all the homework and stuff?
Yeah. I mean,
Okay,
I didn't submit this one yet, I don't think, but I'm like working on it.
okay, but follow up with me, ma. I will give you separate assessments for each unit in geometry, plus one set of extra additional assignments for you to work through and then go for the test. Make sense?
Okay.
If you work those two through, you should be able to pass without any problem.
Okay.
Okay, I started putting, but I'm a little lax. I feel I will do it this week. Before I go to India, I will do. Okay, so that you guys have a lot to work with.
Okay.
Okay, but please follow it up with me. One is the Holt assessments. Holt assessment. Holt is a book. Okay, they have separate assessment resource book, so I can give you all the. This class is entirely CBing, I think. Yeah, this class is entirely CBing, so we should be good. Most of you are CBing, so I'll make sure I'll put it up. I'll put up the Holt assessments this week, but the extra challenge assignments is what you need to definitely do. Make sure you do them unit by unit. I'll also post that and grant access to all of you. Okay? Any other questions? Any other questions with respect to your courseware? Hey guys, videos on 100%, please. Yeah. Any questions? Any other questions? Okay. I have to refer to something. Let me see. We did trigonometry. Okay. Oh, we didn't do. Oh my god. Did we not do the law of sines and law of cosines here? We did. We did? Okay, I see. That's good. So we did. Did you do the homework?
Miss Priya, you didn't post any homework. It was just the one like part 3, 4, and 8.
Yeah, but you could have asked, right? It's no use coming to the class and asking me what is the homework, why did you not put, right? Is there any use asking like that? I don't think so. And the PDF that you had, it already had part 5, 6, 7, and that's what I taught in class as well, right? Ashita, you never got back to me on that, right?
Miss Priya, so I didn't hear you. What did you say?
You never got back to me. Oh, where is the homework? You didn't ask, right?
Oh, because like I thought part 8 was homework, but like I did it and I submitted it.
But you would not have been able to do some of the pieces. Oh, because I see. That's good. If you're done full of part 8, I'm still happy. You know what? Because
Yeah, part 8 was like review, so like it still had questions of law of cosines and sines, so I did it and submitted it.
Clever lady. Good job. Okay, but do 5, 6, 7 as well, guys.
Okay.
Okay, can we move on? Okay, now trig is over, but then I just need to refer something. I don't know whether you guys know. This is where your I'll show you. Wait. This is geometry, right? Let me share my screen and show you what we are covering. You should all know what we are covering, right? I know we are slow, but we'll be slow and fine. Dia, what are you doing in school, Madhya?
Well, I'm in 8th grade, so I'm still doing algebra. But
yeah, you're also see. That's why I asked you to come to this class. Remember?
Yeah,
Yeah,
I remember.
yeah. So, guys, let's go over this. What have we done till date? We are just like that studying something. We don't know what we are studying, right? So, let's go over this. You can raise if you don't know any of these. Okay, I am just going to Teek's website. Okay, coordinate and transformational geometry. Determine the coordinates of a point. Finding fractional distance in line segments. Distance, slope, midpoint formulas. Congruence of segments, parallel perpendicular lines, equation of parallel perpendicular lines. Have we covered all of it?
Yeah.
We've done that. Okay, but please, meaning you can as well educate me. It's not to show, hey, this is what we no. It's both way. You have to educate me. What else we can do? Is this a topic that you guys are finding it difficult? Then we'll go over it again. Okay. We have come to a halfway point, so it's important. Not even halfway, a little more than that. Okay. So you can let me know if there is. Anyway, I'll give you reviews as well. But if you want me to go over anything once more, we'll see. Okay. Based on time, I'll definitely do. Now here, rigid transformation, translation, reflection, rotation. See, I know that you have studied the same thing in grade 7, but what differentiates you in geometry in this transformation piece is the notations, and then the main thing is glide reflections, similarity transformations, glide reflections, the notations you use. Remember, it should be read from right to left. All that stuff only differentiates you in this transformations. Okay, and then determine pre-image image. Okay, see composition of non-rigid transformation is very important, and dilation around a point that's not the origin. Those are the extra things we learn here. And then reflectional rotational symmetry is not a hard concept, it's easy. We have gone through that. Then we went into postulates, conjectures, what are theorems, biconditionals. We did that. Then how to prove a conjecture is false using counterexample. Compare. This is something I did not do. Correct, guys? Between Euclidean and spherical geometries. I did not do this. Right, guys?
Yeah.
This one piece I need to do, because if you're appearing for CBE, there is one sure shot question in this. What is the difference between Euclidean and spherical geometries? Okay. And then coming into the next piece, conjectures, geometrical relationships including angles, parallel line transversals, segments of triangles. What are the main things you know? Circumcenter, incenter, centroid. There's one more, right? Orthocenter. Then finding equations of medians, meaning all are related to slope, finding the equations of lines that passes through a point and perpendicular to a point. It's all you have to connect, because see, altitude, right, that's perpendicular to the base. So basically you will know the slope of one and slope of the perpendicular line, and the line will be going through a point. So from there you have to derive the equation of the altitude, derive the equation of the median. So those cases will come. Interior exterior angles of a polygon, we've gone through, I think. If not, you have to tell me. Angles of circles, I have not gone through with you guys. That's the biggest unit that's remaining. That also comes at the back. Congruent okay. Construction of these, I have not done it with you at all. Okay, let me note down as well. That's a good thing for me. So basically, spherical geometry, Euclidean geometry, that is there, and then construction is there. Okay. Okay, for the construction, right, guys? Rather, meaning I will go over, but at the same time, I really want one help from you guys. I'll tell you what is that help as well. Let me keep closing this. Give me a minute. Yeah. Okay, for constructions, I'll show you. Okay, I have always told you about Math Bits notebook. Please note down, guys. Math Bits notebook, geometric constructions. It's so important that you go through this one. Not everything, you don't need to know everything. 100% you don't need to know everything, but at the same time I have gone through these with you. Okay, but I have not gone through construction parallel through a point. I have not gone through construction of altitude, median, angle bisectors. So these are quite important, and constructing angles 90, 60, 45, 90. Those are the things that you should be familiar with, and I have not gone through that. Meaning, from this to this, I have not gone through that. Would be nice. Meaning, you don't need to know too much. We have studied that the concurrency of medians is centroid. We have studied concurrency of altitude is orthocenter. Concurrency of perpendicular bisector is circumcenter. Concurrency of angle bisector is incenter. We have learnt. Okay, but what a part of the construction we have not learnt is this piece. Okay, but I'm going to post this in the Google Classroom. Those of you who are really interested, you can definitely go inside, look through, learn, and come back, ask questions as well. There will be 1 or 2 construction questions if you are taking the CBE. I'm going to put it as a material here. More than that constructions won't come, and basic constructions only they are going to ask questions. Okay, now triangle inequality theorem, and then we also learnt about Pythagorean inequality to find out if the triangle is acute or obtuse here. Further, you can stop me if you think we need to revise more. Congruent similarity, remember we did all of congruent similarity here. Then what? Verify theorems about yeah, we have done a lot of proof, guys. Right? Base angles of isosceles triangles, mid segments, medians. We have studied mid segments, medians. Apply these relationships to solve problems. Prove a quadrilateral is a parallelogram, rectangle, square, rhombus. For that we went over each properties one by one in quadrilateral some time back. To prove that it is one quadrilateral, we need to be thorough with each property, meaning each quadrilateral's property, then that becomes easy to prove. Okay, now similarity we did. Similarity and congruence was what we did together. This is where dilation from a point that's not the origin becomes very important. Okay, then we did triangle proportionality theorem. Hey, did we do geometric mean? Did we do geometric mean?
I don't think so.
Okay, that is important, guys. We didn't do, you think? I don't remember. Okay, I have to check. Okay, I'll check. I'll note down and check. Okay, and then 30, 60, 90 triangle we did, right? 30, 60, 90, this one we did. Trigonometry we covered and we ended. That's where we are. So what is remaining? We have 2D, 3D figures. Then again 2D, 3D figures, a lot of it is there. Circles and probability. That's a lot. Honestly, that's a lot, because circles is a huge well that we need to dig into, and probability is another huge well that we need to dig into. Now, coming to 2D, 3D figures, right? If you can cooperate with me, this comes from grade 7, okay, but not all of it is in grade 7. Now you are at a point where you will use trigonometry, where you will use 30 for 30, 60, 90 triangles to find out the sides of the triangles and move on. That is the additional part here. So what we will do today, let's see. I really want to finish this for sure, but I'll do it next week, this one, geometric mean, because that's a little concerning to me. Why did I not include that? I don't remember. Let me see. Now, for this week, let's go ahead with 2D, 3D figures. Okay, we will start working on 2D and 3D figures. Okay, yeah. Any questions for me? Any questions, or are you thinking that you need help on any other topic that we said, hey, we have covered, we have covered, we have covered? Is it there, guys? You have to open and be open and tell me, what did you think? What do you think? Do you have any thoughts? No?
Oh.
Okay. Okay, let's go ahead now. 3D, let's go ahead with 3D geometry. 3D solids. Okay, guys. Now, let's go ahead. Do you all know what is the difference between a prism and a pyramid? Do you all know what is the relationship between a prism and a pyramid?
The difference?
Yeah.
Yeah.
Oh, you all know. Okay. Prism always has, see, when you look at my video, they have this structure. The side will be parallel. You see, side is parallel. Whereas pyramid always has a pokey point. Pyramid always has a pokey point at the top. Okay, this one is always a pyramid. This is always a prism. Don't make the mistake. And then look at the base. Okay, look at the base. This is a rectangular prism, rectangular pyramid. Suppose if I have something like this. You tell me, what is this object called? Who can tell me? Who can tell me what is this object?
Pyramid?
Pyramid? What pyramid?
Like oh my god, a trap.
Correct.
Trapezoidal
pyramid. Got it? Yep. So it's very easy to guess these 3D shapes provided you know how to guess them. End, it should be a pyramid or a prism. Okay, the starting point is your base. Any questions, guys?
Wait, is it slanted like just because you made it like that, or is it always supposed to be slanted?
Just because, okay, okay. Since you brought it up, I'm going to tell you something. Suppose if the pyramid is standing upright like this, it is a right pyramid. Meaning, okay, for at least for cylinders, let me go ahead and show you. This one is a right cylinder, because why it is called a right cylinder? These things are conceptual. See, the base and the height are perpendicular, so it's a right cylinder. Whereas sometimes you'll have cylinders like this. What is this cylinder? There's an angle, do you see, between the base and the height? It's not a 90 degree, so it's called oblique cylinder. Make sense? Okay, now 3D we can finish a little faster. It should not be hard, but I wanted to compare these. These are the solids which we cover in general. See, prisms, see there, triangular. Look at the base, start with that, and then whether it's a prism or the pyramid. Okay, now you have cylinders, cones. You know what are edges, bases and vertex? Dia, do you know what are edges, bases, and vertex?
Yeah, I do.
Okay, everybody knows, guys. Vinisha, do you know, ma?
Yeah.
Okay, so when you look at the cylinders and cones, they don't have edges. Okay, they have a base and a vertex. Okay, edges are the lines connecting the vertices. Okay, now with all this said and done, let's say, how about this? What is the base of the cylinder called? What shape is the base of the cylinder?
A circle.
Yeah, we don't say circular prism. Cylinder is a circular prism. We call it a cylinder. You got it? Circular prism. It's a circular prism, right? Circle base prism. It's not, we call it cylinder. Okay. Now, let's say, how about this one? The hard, this one is easy. Okay. I want you to tell me the number of edges, faces, and vertices. For this figure, can you tell me the number of edges, faces, and vertices? Anybody, guys? Do you know what are the
Wait, do you want us to type it in the chat or?
number? We'll discuss now. Because these are from your base early elementary school. Go ahead. Phases.
5.
Phases is 5 because base and then the sides 5. Edges
There's 8.
8. Good job. Why 8? Bottom 1, 2, 3, 4 and then connecting to the top. 8. And then vertices are 1 and bottom 4, right? 1, 2, 3, 4, 5. Any questions, guys? Okay, now I bring the harder part. Okay, I gave you a easy example. Okay, let's see the harder one. How about a sphere? Number of bases, face edge vertices. Face edge vertices. What is it, guys? It's easy though. Go ahead. Go ahead, guys. Oh my gosh, what did I do? None. Everything is 0. You got it? How about a cone? How about a cone?
1 vertex.
What is it, ma? 1?
1 vertex.
Correct. 1 vertex. Good. 1 vertex. Let's point out what it is. 1 vertex.
1
and then?
1 face.
Base. Faces.
1.
1. That's what I also think. Edges.
0.
None. Yep. You all got it. So that was the hard piece. Okay, the rest of it you can guess. Okay, you can sit and count and guess. Okay, that you can do. Then what else? Okay. Now, there are 2D shapes. Okay, there are 2D shapes which I can spin around an axis. Meaning, think of an axis. Think of the y-axis. If I spin a 2D shape around an axis, it becomes a 3D solid. Do you see what I mean? So what are the 3D figures you think can be called as solids of revolution? Solids of revolution means you spun a 2D. Okay, let me show you an example. If somebody is not getting it, I'll show you an example. This is an axis. This is the y-axis. Now, let's say, okay, how about this? This is a triangle, right? I spin this shape. I spin this shape around this axis. What does it become? What does it become?
A cone.
A cone. Do you see? It becomes a cone. Okay. So here, the solid of revolution is what? Cone. Makes sense? Like this, I want you to answer a few questions. Because you should know, if you rotate a 2D object that I give you, what will be the solid of revolution that you get? Okay, let's try this one. Um, okay, uh, how about this? Okay, tell me this one. I don't. Okay, how about this? If you spin this 2D object, what is the shape we are going to get? Okay, you spin this shape. What do you think? What do you think is the solid of revolution you'll get? We'll discuss, guys. Please open up.
A sphere.
Good job. You're going to get a sphere. This one?
A cylinder.
Good. This is going to be like this. This is going to be like this, and it's going to rotate. Good. Cylinder. This one? Next one. Cone. Good job. This one? That's a tricky one.
Semi-sphere?
Do you call it a semi-sphere? What do you call it?
I'm not sure.
ERE. Hemisphere. Hemisphere. Half a ball, right? How about the next one? That's a little tricky. Who's going to tell me the next one? Who's going to tell me? The next three are difficult. I want you to think. For the others, what did you do? So what will this become? Do you see, guys? Dhruv, you want to give it a shot? Those are
I don't know actually. I don't know what it is.
nothing. We'll do it together. Okay. So basically, what did you do? When it rotated, we attached something like this for this one. This we attach something. Similarly, for this one, we attach something like this. You rotate down, and that became this. Here as well, same thing happens here, right? What will be that object? You will develop something like this, right? And then on the top, what will happen? Same thing will happen, right? You see, guys? So that object will turn into like this. Does that make sense? Make sense?
Is there a name for that shape?
I honestly don't know. Okay, I'll come back on that. I'll have to look into and come back. What is the next two? What is the next two?
Miss Priya?
Six is a cylinder, I think.
Then what is the difference between this and that one? There is a name for that I know. Go ahead, guys. You can shout out.
Would it be like a cylinder with a hole in the middle?
Good. So what is it called? It will be exactly a cylinder, but because of this gap, right? What is that called? What is that? What is that? What is that gap? Meaning, I should not have drawn it like this. It'll be like this. Right? So this will be the solid portion. What is that called? Make sense? A hollow cylinder. Now, what is this? This is an easy one though, but it just takes a little bit of thought. The circle keeps on repeating. Circle. Circle is winding around, right? Circle. So what? It becomes what shape?
Like a tube?
Would it be like a donut shape?
Yes. Yeah. Yes. It's a donut or tube. Make sense, guys? See that circle keeps on becoming a circle. It becomes a donut. Make sense?
Miss Priya?
Yeah, ma.
For phi, do cylinders always need to be like
having a right angle.
Which one, ma? For which one you're asking of you?
For 5,
For 5.
do cylinders always need to have like a right angle from top to bottom?
That is, the right cylinder will have a base that's perpendicular to the height.
So the bases need to be same size? Or can they be dilated?
I don't understand what is your object you're comparing it with.
I'm comparing with like a trapezoid, like a trapezoidal kind of cylinder.
There is no, okay, trapezoidal prism, we'll say. There is no trapezoidal cylinder, right? Trapezoidal prism, you mean?
Cause like
Sorry, Avyukta, I have not understood your question. You can educate me with your question better. Go ahead.
so like for that for 5, the base was like a little bigger than the top
Yeah.
base.
Yes.
Yeah.
Yeah.
So I was saying, could that also be considered as a cylinder?
It should have some speciality around it, because this cannot be treated as a cylinder for sure. Cylinder needs parallel, you see, parallel cross sections. This is not even parallel. You see the trapezoidal cylinder. Oh, that's where you're asking whether it's a trapezoidal cylinder.
I mean, it could be.
No.
Yeah, sure. Okay.
It cannot be. I'll tell you why it cannot be a trapezoidal cylinder. I am pretty sure it's not a trapezoidal cylinder. Why? You know, the base is your starting point. You see, just because of this shape, you cannot call it a trapezoidal. You got it?
Oh, okay.
You always start with your base shape. You can call this as a circular prism. You got it? So this cannot
okay.
be a trapezoidal cylinder. I will check and tell. Hold on. I feel like it's a hollow something should be there. I feel. I'll check. Okay, now. Okay. You know, if there is, what is the shape first of all? Do you know the have you heard of the word cross section? Have you heard of the word cross section? What is this figure? What is this figure first of all? What's this figure? Yellow color figure. Square.
Pyramid.
Pyramid. Good job. So the horizontal cross section of a square pyramid is a square. Does that make sense? What is the vertical cross section of the same figure?
Triangle.
Triangle. Good job, guys. Do you get it? So you need to know what is a cross section. If they may give you different shapes and ask you what is the vertical cross section, what is the horizontal cross section of that shape, of that 3D object, then you need to know what is that. Okay, so that's there. And what else I wanted to let's see, wait. Okay, now I don't want, okay. Oh, okay, let's see this one. I'll ask you this one. I don't have a figure of that. How about this? This is a cylinder, right? What is the vertical and horizontal cross section of the cylinder? That's easy, right? What is the vertical and horizontal cross section of the cylinder?
Is the vertical a rectangle and the horizontal a circle?
Very nice. Horizontal a circle, vertical is rectangle. Nice. One is circle, one is rectangle. Great. What is the oblique or the angled cross section of the cylinder? What is the oblique or the angled cross section of the same cylinder? Think about it. I did not draw. If I draw it, you'll get it. I don't want you to get it.
Oval?
Good. Oval, or I can call it as an ellipse. Does that make sense? Okay. You're going to give me 1 minute before I forget what is that object. I want to know what is that object called. Okay. Now let me go back. Okay. See, what is this cross section? The green color, what is that cross section of this figure? What is the cross section of this figure? The green shape. If I cut out that shape, what is the cross section of that shape? Go ahead, guys. That's easy, not a hard one, guys. You're just overthinking. If you cut out that shape shown, right, what is the cross section there?
Like a square or a rectangle?
Why?
Would it just be
Triangle.
triangle?
Yeah, it's just a triangle, right? I'm going to cut it, meaning think of it like a wooden object, okay? I'm going to saw it here. Completely, I'm going to cut it off. So it's going to be a triangle that remains there, right?
Oh, okay. I thought like the backside would be flat. So I thought it would be a square.
But you're going to cut it off in this shape, right, Amma?
Oh, right, okay.
Okay, so it's going to be a triangle. Now let's see this one. This one is nice. Slowly think, all of you think. Okay, give a moment, don't shout out. For this one, I'm showing a pyramid to you all. Okay, it is basically a square pyramid. Okay, but I want to know about the cross section of all the three slices. Let's see. Go ahead. What is that? Oh wow, it is the frustum of a cone, or it's also called a truncated cone. I talked to you about this, right? Yeah, I talked to you about this, right? This shape. This is called the frustum of a cone. Or you can call it as a trunk, because they cut it off here, right? Truncated cone. But good question. Can we move on? I had to look for and then only tell you guys. Can I move on? Okay.
Yes.
I hope.
Yeah, you can.
Horizontal slice, angled slice. What shape does it give, guys?
The horizontal slice is a square.
Good. Oh, since we cut, I said it's a square prism. Okay, fine. Okay, I'll leave it to you. If I had said rectangular pyramid, then you should say rectangle. Okay, great. Then
The angled would be a rectangle.
that's a little tricky. Okay. Let's come to the vertical slice. Vertical slice. What do you think?
It would be a triangle.
Yep. Vertical slice is a triangle. The middle one.
Would it be a triangle too?
Is it a rectangle?
It is some form of a quadrilateral.
Trapezoid?
It's a trapezoid, yes. It's a trapezoid. Okay, yeah, that was a difficult one. Okay, now how about this? How about this figure? What is the vertical cross section? This one is easy though. What is the vertical cross section? There's somebody else this time. Whoever has not answered, please try. Shreya, you want to try, or Harshita, you keep quiet. I know that you know everything though. But somebody else, whoever has not answered.
Would it be like a triangle?
Yes, ma'am. It's a triangle. Good. Okay, nice. What else is there? Okay. Oh wow, this is a good one to do. Let me see, guys. Hold on. Yeah. Okay. 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 I want you to tell me the shape of the cross section from the vertical slice of this figure. I'll tell you, I'll write it down. You are making a vertical slice in the figure. Just because the figure is lying down, it's a vertical slice that I'm doing, okay? Okay. Now, what will be the shape of the vertical slice?
Can I say the shape or is it try to say in chat?
You can describe you cannot say the shape directly, I feel, but you can describe vertical slice na like this, right?
Like,
Ma?
I have a question. If it's a circular base but you cut vertically, it's still gonna be a flat like surface though, right?
True, ma, that's where I'm saying, are you thinking about a vertical slice like this? Is this you're thinking? Oh, I'm sorry. I was thinking of vertical slice means what? The base is a circle. The base is definitely a circle here, and I am thinking of this slice. So what you'll end up with? You'll end up with seeing this. Do you see it?
Yeah.
Yep.
Wait, I thought that's a shape. Never. I thought that was a.
That's the shape. That's the shape.
That's
If you make
that's a pentagon, but
come again, ma?
I was gonna say pentagon.
Oh, it's a pentagon. Correct. Yes, I agree with you. Can we move on? Okay, now you know about all these cross sections and stuff. You're good, but let's see. Oh yeah, this is a good one. How about this? How about this? Just tell me what is the answer to this. Please think. Don't blurt out. Wait. Wait for others to think, and then we'll blurt it out. It's a good one. They have given it hard. They have made it hard. Literally, they have made it hard. What is that? I don't want to give you the shapes A, B, C, D. Just tell me what will be the shape formed by the intersection. What does each of you think? They've drawn it hard, that's all. But actual answer is very easy. What is the answer?
Can we say it?
Yeah, ma.
A circle?
Yeah. Some definitely find it tough to visualize. Yes, it's a circle. Okay. Now let's go ahead. I wanted to. Okay. Okay. What is this called? Meaning, what is the difference between this and this? See, okay. What is the difference between this object and this object? I think we discussed this, but I don't know whether you remember. Let's see. What is the difference between these two objects? We did discuss a few minutes back, but not on this object though. Something else I said. What is the difference between these two figures?
Do we shout out?
Yeah, please. Thank you for asking. Go ahead.
So like the top edge is like in the middle for the second one.
Top edge?
Is in the middle, and the first one is on the left.
Correct. But there's a bar. Okay. If I show you this, you guys will find out. That's the difference. This is what I discussed with you, so I gave you that. Let me see.
Is the one on the top right and the one on the bottom
Correct. Correct. What is the difference between here is the same as, but these are different solids though. Let's see. See, this one is what type of a cylinder? A right cylinder. This one is oblique cylinder. This one is right prism. This one is oblique prism. Any questions, guys?
No.
Okay, now let's get into surface area. When it comes to 3D solids, please don't memorize any formulas. Okay, there is no point memorizing formulas. Even if the notes are going to give you the formulas, don't memorize any formulas. It's not worth it. Okay, you can find, you can understand. Let's go with understanding. Okay. Let's go with understanding how it all works. Okay, we are not going to memorize. Okay, let's see this one. How do you find the surface area of this solid? Oh, what is that? 460, find the height. Oh, okay, what is that? Okay. Oh, lateral surface area. Okay. You know what is the lateral surface area? What is the total surface area, guys?
Yeah.
Lateral surface is like without the bases, right?
Yes, good job. With the yes, lateral means only the sides. The top and bottom are gone. Okay. Total surface area means the side area plus top and bottom. Does that make sense? Now let's see this one. Here the lateral surface area is 460 inch square. What is the height? How will I do this? Lateral surface area of this solid is going to differ a lot. Okay, first this side. This is going to be the same as the left side. So 8h plus 8h. Guys, okay, beat any prism before I go here, right? Beat any prism. How many sides, how many faces it's having? Top, bottom, this is constant for all. Top, bottom, right, left. If you know this concept, there is no need to memorize any formula. Top, bottom, right, left, front, back. Any questions, guys? Always they exist in pairs. It's very easy. Okay, area of all of this is the total surface area. Remove this becomes your lateral surface area. Okay, see the shape of each face. You can yourself find the area, add them up together. Don't go by formulas. Okay, formula today you'll memorize. Tomorrow when you go to the SAT exam, nobody is going to give you formulas and you'll be stuck there. But if you understand and do, it's very easy. So this side it's 8h. The same with the opposite side, left side, right? And then lateral surface area, right? So I can't calculate the bottom. So I'm going to do this. 15h. This is 15h front. Back is as well another 15h, right? All that front, back, right, left I added is equal to 460. That becomes 30. 46h equal to 460. H is equal to 10. Any questions, guys? If you understand and do, really there's no need to memorize formulas in 3D geometry. Okay, and for any volume I didn't go yet there, but this is something coming from your previous years. Volume, if you're asked, it's always base area times height. Any questions on that? Volume is always base area times height. The base area, whatever is your base area, if it's a rectangle area times the height, that gives you the volume. Okay, now let's go ahead and try this one. First we'll cover surface area. Okay, coming to okay, first what is this, you tell me. After that we'll see. We want to calculate the total surface area and lateral surface area of this. Let's see. I don't know whether I can give you this. What is this object? What is this object?
A hexagonal prism.
Yes, but why? What are those stick on those? What does it mean? What do they mean?
That, like,
Sides are congruent.
the sides are congruent, yeah.
Yep. It's a regular hexagon. Regular means all sides are equal. Regular hexagon. And it's a hexagonal prism. Okay, nice. Now that the case, right? They are not going to give you anything. They are just going to say it's a regular hexagon. The side is 4 meter. The side of the hexagon. Let me see how you all think. Okay, the side is 4 meter. The side of the hexagon is 4 meter. Let's draw it nicely, guys. 1, 2, 3, 4, 5, 6. It's a regular hexagon, and the sides, right? These sides are 16 centimeter. This is 4 meter. Now tell me, guys, what is the lateral surface area of this solid? What is the lateral surface area of this solid? And what is the total surface area of this solid? Lateral surface area of this solid. You want me to draw it better? I can draw it better. I don't want this. Yeah. What is everything is given, meaning what can you use? Whatever you have studied is going to come handy. So let me redraw it. 1, 2, 3, 4, 5, 6. Oh my gosh, what did I do? Okay, now it's going to extend like this, extend like this, extend like this, extend like this. Now again, and then this is going to go like this, and then this is going to go like this, for what I'm doing. I didn't do a proper job. Okay. No, I didn't do a proper job at all. Okay. Go ahead, guys. Okay, you have a hexagon, a regular hexagonal prism. First of all, we need to find the area of a hexagon, okay, which I have not covered yet. This is a pentagon. This is a hexagon. How will you find the area of a polygon? This is a hexagon. This is an important concept. This is new to you though. You know what? In this case, right, half perimeter times apothem. This one I want you to memorize. Half perimeter times apothem. What is this apothem? Apothem is the distance, perpendicular distance from the center to one of the sides. This is called apothem of a polygon. Any question? That's the apothem. Here, that's the apothem. Half times perimeter times apothem is the area of a pentagon. Now, what is the area of the pentagon here? Any thoughts? What is the area of this pentagon? Because otherwise we can't calculate the total surface area. This one everybody will calculate, I know. If I say this lateral surface area is very easy for you all to calculate because it's just the 4 rectangles, you're going to add it together. That's pretty easy, not a difficult one. Whereas, what is the area of the base? How to find? I said that this was 4 meter, right? But what is not present? You can use some of whatever you learnt. It's not a hard thing. You need to know for finding the area of this, right? This piece, right? You need to know half times perimeter times apothem. You have the perimeter with you already, I know. Right? The area of that piece we are discussing. Now, half perimeter is very easy, 6 4s are 24. What is this apothem? How do you find this? Guys, I want you to try, please. How will you try? We have studied. If you figure it out, you'll remember forever. How will you figure that out? Try, guys. The best part is it's a regular hexagon. That's the biggest clue. If it's a regular hexagon, what happens? What does it form at the center? What does it form at the center? See, a regular hexagon means all the sides are equal, correct, ma? Okay, the best part of the regular hexagon is that, okay, at the center. So what type of triangles are these? What type of triangles are these?
Equilateral.
What is that?
Equilateral.
Equilateral. If they're equilateral, what does it mean? And for an equilateral triangle, remember we drew a perpendicular bisector and studied something. What did we study? For an equilateral, there was an equilateral triangle. I don't know whether you guys remember though. It was long back. Let's see. There is an equilateral triangle. You draw a bisector. You draw an angle bisector. So what did we study about that? What did we study? The angle bisector of an equilateral triangle forms what triangles?
30, 60, 90.
30, 60, 90 triangles. As a result, would you be able to find the apothem? Because you know this is 4, you know this is 2, 2. Now you know one side of a 30, 60, 90 triangle. Which side you know? You know the side opposite to 30. So that is, you know 1x. And then the rest of it are 1, root 3x and 2x, right? So apothem is what? Can I say 2 root 3? Guys, are you all with me?
Yes.
Okay. So apothem is 2 root 3. Do you see it? Now you know the area of the hexagon. That times 2. Why? Top and bottom. So this is 48 root 3. So the top and bottom amounted to 48 root 3, which needs to get added to lateral surface area. What is the lateral surface area of this hexagonal prism? You are going to calculate the lateral surface area. From then on, we can easily get both the surface areas. Can you find the lateral surface area? That's not a hard one, right? You find the lateral. Yeah. Yeah, ma?
Would the formula for area only work for the hexagon?
No, it works for polygons. Okay. It works for the polygons, meaning polygons, the pentagon, regular polygon, hexagon, everywhere you can use that. Okay, but one thing I want to show you now itself. I'll come back to the problem. No problem. The problem is here. One thing what I want to show you is, I have gotten deceived. Okay, when I was doing problem, okay, in one of the classes, right, I do come across the same problem. I have gotten deceived. Here, this is a regular hexagon. So the central angle is 360 degrees, right? 360 divided by 6 is 60 degrees, 60 degrees, 60 degrees. So that forms 30, 60, 90 triangle, okay? So the regular hexagon, since it's divide itself into 6, 360 divided by 6, right? Each is a 60, and when you bisect it, it becomes a 30, 60, 90. Whereas that does not happen for what? Please don't think these are equilateral triangles. Even if it is a regular pentagon, what will happen? What are these angles? What is each angle here? 360
divided by 5.
Divide by 5, which is what? 72, I think. So please be careful. You got it? This one, you are not going to get a 30, 60, 90 or a 45, 45, 90. If you get this, in those cases, for you to find the sides, right, you can draw perpendicular and use what? Trigonometry to find the sides. Okay, law of sines or law of cosines you can use to find out the sides of this triangle if it is not a right triangle. If it is a right triangle, then you can go ahead and use sine cos tan. Got it? Okay, but in a pentagon, the central angle is so deceptive. They can ask questions on this and this. Whereas in a hexagon, if they give, then the central angle is the 60. And if you draw the bisectors, right, they nicely form 30, 60, 90 triangle. You can find out the sides very easily. But the same concept you will tend to apply even if it's a polygon, which is pentagon, which is not right, because the central angle is not 60. Makes sense, guys? You'll come across the problem when we go, right, when we go through this. Now, can we find the lateral surface area of this structure? 4 meter, 16 meter. Can we try, guys? What is the lateral surface area of that pentagon?
Is it 384?
Correct, ma. So what did you do? Can you tell us? 16 times 4?
And then 16 times 4 is 64, and I multiplied that by 6.
Good job. Okay. Now, I'm going to go ahead with a complex problem again, okay? Meaning, at least we'll come up with ideas, and after that you can go home and try more, okay? How about this? I want to find the surface area of this figure. You're going to find out, okay? Meaning, I don't want computations. I don't want you to be doing computations, but let's think about the problem. Okay, we want to find out the total, the lateral surface area or the total surface area, whatever it is. Okay, what are the shapes you need the areas for? Rectangles, all you will do. Okay, but the problem comes with the trapezoid. You have the bases, but you don't have the height. How are we going to find the height of the trapezoid? You don't need to do the problem, but let's think about the problem here. How do you find? See, each side area you have to measure if you want the total surface area. Okay, the back, I said, right, the 6 faces are always the same. The back is easy. Front is as well, when you think about it, it's a parallelogram. Okay, front is easy, top is a rectangle, bottom is also a rectangle. But the sides, right side and left side is a trapezoid. Let me draw it big. It's a right trapezoid. They've given something in here. What are we going to do to find out the height? I know only the bases, but to find out the area is half b1 plus b2 times height, right? How do you find? Come on guys, try guys. You tell me please. What do you guys think?
Would you just draw a line and like
Nice.
make it a 30, 60, 90 triangle?
Yeah. You will just draw a parallel line to this, making it a 30, 60, 90. Now you know this is 5, you know. So this is 4, you know. So you know one side of the 30, 60, 90, you can find the other side. Make sense, guys? So we'll do one more and then I'll let you go. The last one, let's see. This one is also tricky. Meaning the way you think, broaden it a little bit, then it becomes very easy. Okay, how about this? This one is a little tricky, honestly. Okay, for this one, I don't want you to compute anything. We want to find only the lateral surface area. We'll do this and see, okay? With the computation, we'll do this and see. Okay, lateral surface area I want. For this figure, I want the lateral surface area. See, the thing is, it's all the same concept from 7th, but you're going to apply trigonometry or 30, 60, 90 or 45, 45. Diya, have you studied 45, 45, 90 and 30, 60, 90 triangles, ma?
Yeah, I have.
Okay, good. Okay, so for this one, how are we going to find? Meaning, at least we'll say what are the side areas. That's enough. Can we try? So this one, what shape is this, right and left? Right and left, what shape is this, guys? Tell me, guys.
Is it rectangle?
Yeah, why it is a rectangle? Clearly given, right? Why it is a rectangle?
Because it has the right angle.
Yep, but for that rectangle, you can't find the area. Why? Can you find the area? No, you can't, right? No, you can't. Because you don't know the height, right? So how can you find the height? This height you don't know, which is the same as this. But how can you find that?
Would you?
We can use trigonometry ratios.
Yes, you can use trig ratios here because this is a right triangle. So you can connect what and what. This you know, they've given 18 centimeters. So opposite by hypotenuse. Sine 59 if you use 18 by x. X will be 18 by sine 59. So that x you can find out and say x times 16, x times 16. Make sense, guys? For the front, what is the area of the front?
18 times 20.
18 times?
20.
Yep, because it's a parallelogram. Base is 20 times the perpendicular height is 18, front and back. Right and left we found, front and back we found, and then top and bottom is, top as well is a right angle. You see here, they have marked it. So what is the top and bottom area? 20 times
16.
16, yeah. 20 times 16. You got it, guys? Now the only hardest part is you'll have to find out x. That is the same as this height. That you need to use it here. Make sense, guys? I didn't work these out. So homework is there, but let me know if you can't do. Does that make sense? Can we stop here? Okay, we'll do this next week. Okay, have a nice week ahead. If you have questions, please take. Diya, are you doing your homework, ma? I didn't see.
Yeah, I turned in my homework for this week.
Honestly, I've not
Well,
seen.
I turned in part 3, 4 through 8. Like the ones we did last class.
Are you understanding and doing it?
Yeah, I am.
Okay. So you're good with whatever is happening?
Yeah, I still need to review like the past stuff. Like I'm still working
I
on
know.
that, but
I'll leave it to
for
you.
right now,
You have
yeah.
big breaks coming. So
Yeah.
whenever you have a break as well, you can review.
Okay.
Okay, yeah. For some reason, my video is not great. I don't know why. Okay, guys. See you all next week. Okay, if you have questions, stay. Yeah. Bye, guys. Have a good week ahead.
Miss Priya, I have a question. I don't know if I should do this over the summer because I kind of regret not like skipping geometry because I realized it was like easy.
Do
But
it. Wait a
I
minute.
don't know if I should skip like algebra too because I heard like bad things if you skip, like it comes mainly on SAT and stuff. So I don't really know. That's why I want to hear